on to question 12, which is to do with two-way tables. So how this one's different from the previous one we did, we don't have the table made for us. We've got to create our own table, and we've got to a bit of analysis. Okay, let's have a read of the question. A new test is designed to determine whether a patient has cystic fibrosis. Okay, this is like an inherited disease that messes with the cells that make mucus. So the mucus comes out a bit sticky and gross, can clog up pathways. If the test is more than 4% inaccurate, it is deemed to be unusable. Okay, so that's important information. Unusable if it's 4% inaccurate. Okay, of the 215 people without the cystic fibrosis gene, 2 received a positive, 88 there were 88 positive results and 220 negative. Okay, so we create a two-way table. We know it's going to be positive, negative with the gene and without the gene. So a bit of planning before you start straight away. So maybe we can be like test result. Test result will be here. We'll have positive, negative, total, and we'll have with cystic fibrosis. We'll have without cystic fibrosis and the total. I think that's a good plan. I'm going to draw up the table and then we'll move on. Okay, I've got my table. Now I'm going to reread the question. Of the 215 people without the cystic fibrosis test, or of the 215 people without the cystic fibrosis gene tested, so the total of 215, there, 2 received a positive result. So 2 received a positive result, and then let's keep reading. There were 88 positive results, so 88 positive results and 220 negative results. Not so difficult. Then we just need to fill out the missing blanks there. We've got 86 plus 2 will give us 88. Here 213 plus 2, it gives us a total of 215, and 7 plus 213 will give us 220. 220 plus 88 is 308, and 93 plus 15 is 308. So we've got our values in there, and so we've done one of the things that the question is asking to do is to complete a two-way table. Now we need to determine whether the test will be used, meaning it needs to be less than 4% accurate for us to be for it to be able to be used, and then we need to evaluate our findings. So we've done the two-way table. Now to determine whether the test will be used, the two ways we could do this. We could find out how inaccurate that is straight away, and I think that is really the simpler way to do it. So if you've got the gene, right, and it comes out negative, that means that's a false positive. That's 7. So that's a false positive. That means you had the gene and you came out negative, so that test didn't work. So that's the inaccuracy part of it. And if you did not have the gene and it comes out positive, again, that's a false positive. Because if you did not have the gene, you should not be getting it. So the 7 and 2 is the false positive, so the inaccurate result is 7 plus 2 over the total of 308, which is 2.92%. And because it's less than 4%, this test is deemed reasonable. Okay, then it says evaluate your findings. So you can just say we can find out the so if you do 100 minus 2.92, we can find out how much its accuracy is, and that's 0.08. You can say that it has a high success rate, But then you can also then talk about, always whenever you have a two-way table, you can talk about the sample size. So small sample size. Or maybe do it with 100,000 people, then it'll give you more accurate results. Okay, that's question 12.